Factoring. Here we have differences of squares. It's something squared minus something squared, hence it's called differences of squares. Differences of squares always factors into two parentheses that are the same, except for one is a plus, one is a minus. What you put in the beginning of each parenthesis is whatever was being squared. What you put in the end of each parenthesis is whatever was being squared at the end. Here we have differences of cubes. Something cubed minus something cubed. It factors into this. Here we have sum of cubes. It factors into this. Sum of cubes and differences of cubes are very similar in how they factor, with the exception of the first sign here is different. The first sign always matches with what you were given. The second sign here is always opposite the first sign. And the last sign is always positive. Those are referred to as our specials when we're looking at factoring. The first thing you want to do is to factor out your GCF, your greatest common factor. The second thing you would want to do is to look for specials. Specials are the differences of squares, sum of cubes, and differences of cubes that we just talked about up here. We also then have our third idea that we want to look for, and that's if we just have three terms, we want to just put it into two parentheses side by side, in which we are basically trying to do the reverse process of FOILing. Then the last one is, if we have four terms, we want to factor by grouping. Your first step is always to look for a greatest common factor. Here we have a greatest common factor. We have a 2 that goes into each one. The both terms have a u, so we can pull that out. You then got to ask yourself, okay, a 2u times what gives me a 4u squared, which happens to be a 2u. Then you have your minus, and then you got to ask yourself, a 2u times what gives me my 2uv, which is a v. Same idea over here. You always start out with your greatest common factor, but in this case there is nothing that goes into your 8, your 7, and your 10. Since we have three terms, you want to do two sets of parentheses side by side. Well, when you're doing your FOILing, you know that when you take this term times this term, the first terms, you got to be able to get your 7x squared. The only way to get a 7 is with a 7x and a 1x. Now, we do have options for how to get this 8 at the end. The 8 at the end is a negative 8. That can come from a 1 and a negative 8, negative 1 and an 8, and a 2 and a negative 4. And, sorry about that. And then here's your other one. Well, we also want to go ahead and try to figure out, okay, which pair of numbers that we have here actually works here at the end. So then it's more or less just a matter of trial and error. We're going to try a number. We could try our negative 8 here and a positive 1. And then you would want to check your inner terms and your outer terms to see what you're going to get, to see if you get this correct middle term. And it's just a matter of trial and error. Here we'll get a negative 8x and a positive 7x, which do not add together to give you your 10x. So then you could try flip-flopping these two to see if that makes a difference. Try the plus 1 here and the minus 8 here. Then you would get a negative 56x on the outside, a 1x on the inside. Does not work to give you that. Well, you keep doing that trial and error with all your different options here, and you end up finding that your negative 4 and your 2 end up working. Well, we want to keep doing that over here. Always look for that greatest common factor. In this case, there is no greatest common factor. Then you want to go ahead and factor. Well, you have more than just one option to give you 12. Last one we had a 7. There's only one way to get 7. To get your 12, you have this. To get your negative 6, you have all these options. Typically speaking, whenever you have something that's relatively small in front of your middle term compared to the outer two, you want to then choose the factors that are closest together. These are the closest together, or this one here. They're both 5 apart. These are farther apart. So typically you want to start with that if your middle term is small. So we'll start with the 3 and the 4. Now we got to just go ahead and try those one at a time to see what works. So if we go ahead and try this, you'll notice that when you do this and you do this one here, that's an 8x and that's a negative 9x, which does give you your negative 1x. If you had tried these two flipped or one of the other options, you would realize that when you check your inner and outer terms, it doesn't work. So it's a matter of trial and error. So you always want to take out your greatest common factor. Here our greatest common factor is an x. Since we have only two terms here, we want to look for a special. Is it differences of squares, sum of cubes, or differences of cubes? Well, it's a subtraction, so you know it's a difference. It's not the cubes because we have an x squared. So you're going to still have that x here in front. What's being squared here is an x. So you're going to put an x in the beginning of each parenthesis. What's being squared here? It's a 5 that's being squared to give you your 25. So you put a 5 in the end of each parenthesis. And so you get an x plus 5 and an x minus 5. That goes back to the specials of how they factor on the previous slide for differences of squares. One of the signs is always plus, one of the signs is always minus. So here we want to look for difference or greatest common factor. There is no greatest common factor, but we do have two terms subtracted. So you want to see, is it differences of squares or differences of cubes? In this case, it's differences of cubes. Your 8 is really a 2 cubed. Your 125x cubed is really a 5x all cubed. So then when you look at your differences of cubes formula, wherever you see an A, you want to replace it with a 5x. Wherever you see a B in your differences of cubes formula, you want to replace it with a 2. So when you do that, you get this. Now a lot of people will write this right here, your 5x with the squared without the parentheses. But keep in mind that it's whatever your A was, all being squared. Our A here is our 5x, so we have to have that in parentheses. Without the parentheses, the square would not apply to this 5 right here. So now we can simplify a little bit. That goes down to this here. Then we get a 10x. And then we get a 4 here at the end. Well, you want to go factoring with the greatest common factor again, but there is no greatest common factor. When we have 4 terms, we want to try grouping. You just want to try putting them together into pairs. Here we're going to try the first 2, and we're going to try the last 2 and group those. Well, what can we pull out of the first 2? Well, they both have a's, they both have y's, so we pull out an ay, leaves us with a 2y and a minus x. Here, we want to go ahead and pull out our 3 and our x, leaves us with a 2y and a minus x. If you're factoring by grouping, and you pull stuff out and both parentheses end up being the same, that's what you're looking for. Now, keep in mind, if we had this right here, and I wanted to distribute this through, I'd take my box times my ay, and I would get this. I'd take my box times my 3x, and I would get this here. That's really exactly what we have up here, except we have the right side. What's highlighted here corresponds to what's highlighted up here. So all we're doing is really pulling out that greatest common factor like we would here. We'd pull out our box to get back to this. Here our box is our parenthesis. We're going to pull out that box. Well, if our box gets pulled out, that's gone here, leaves us with an ay and a plus sign. Here our box is gone, gets rid of that's gone, and it leaves us with our 3x.